Okay, let's look at this particular relation. And once again, is it a function? So if we do the vertical line test, we take our ruler and we move it over to where our graph is. And we can see when I put that ruler right on top, that ruler is touching more than one point. In fact, that ruler is touching an infinite number of points. So we can see that for my x value, I'm getting, so let me look right here, my x value, which is 1, 2, 3 at 4, is giving me a y value of 0, but it's also giving me a y value of 1, it's giving me a y value of 2, it's giving me a y value of 3, it's giving me a y value of -3, and these lines go forever. So it even gives me a y value of -10, a -1,000, a y value of 1,000,000, okay? Because that line goes forever. So this is not a function. Not a function. In fact, if we were going to write the equation of this line, the slope is crazy. So this is not, if we were to go to y equals mx plus b, well, first of all, let's talk about b. That's a nice place to start when we talk about this. B is our y-axis intercept. Our y-axis intercept. So is this function, is this relation touching the y-axis? No. So we can't even write 0 because 0 would be right here. It's not that, so this does not exist. So that does not exist. Okay? So then we have no y-intercept. So then let's look at our slope. Well, remember our slope is rise over run. So I'm thinking up and over, up and over. So let's start from this point here. If I go from this point to this point, I jumped up one step. So that would be my rise. So my rise would be a 1. Now my run is either going to be to the left or to the right. So in order for me to go from here to here, I go up 1, but am I going to the left or the right? I'm not moving left or right. So not moving left or right is 0. And herein lies the dilemma. I cannot divide by 0 because this becomes undefined. That's undefined. So my y-intercept does not exist. My slope is undefined, which basically is almost like saying I don't really, it's like I don't even know what to call it. It's not even a number. It's exploding. So how do I find the equation of the line? Because I can't use my slope-intercept form. Well, one way to do it is let's look at all of our values on that line. So let's just pick a point. Let's just pick this point right here. Well, that's where x is 1, 2, 3, 4. So x is 4 and y is 1, 2, 3, x is -3. Y is -3. This is where x is 4, y is -3. So let's just go up to right here, this point right here. Well, what's that point? Well, x is still 4, isn't it? Y is -1. Okay. Well, let's go up here. My x is still 4, isn't it? And my y is 1, 2, 3, 4, 5. And my y is 5. So my x isn't changing, is it? My x is the same all the way on that line. So my x is 4 everywhere on that line. So that's the equation of my line. X equals 4. Okay. now that we've kind of gone over some basics of how to determine if it's a function and then figuring out the equation of the line, let's go ahead and talk about domain and range. So remember, domain, let me leave these points showing here. So domain are all values of x that create the line. So what is our value of x? Well, we just see that everywhere along here my value of x is 4, isn't it? So that must mean my domain is simply 4. So if I were going to draw a number line showing my x-axis, the only value I have on my x-axis is 4, which means in interval notation my domain is exactly 4. Don't have a choice. So if we do what we were doing before and we're looking on our graph on our xy coordinate plane and I move my ruler from left to right until I hit the line, I hit it at 4. And if I keep moving, it's not there anymore. It's off 4. So the only place where I have x values is where x is 4. Okay, so now let's look at range. Range is a little different. So remember, with range, we're going to look for our upper value and our lower value. Okay, so I'm going to put down here range. And we're going to start from the floor and go to the ceiling. Well, what do these arrows mean? That arrow means that this keeps going down forever. So where's my lowest forever? My lowest forever is at negative infinity, isn't it? Because this keeps going down forever, it's going to negative infinity. And we have to remember, this is going forever up. So where is that going? Well, that's going to forever infinity. So when I'm looking at my x and y values, I can see my x values are all staying the same at 4, but my range is changing. My lowest y value is negative infinity. That's my floor. And my highest value is infinity. That's my ceiling. So if I were to draw my vertical line that represents my y-axis, I can see that all the values corresponding here is everything. So all my values for y make up everything. So that means my y goes from negative infinity to infinity. So I'm going to write that. Negative infinity to infinity. So remember, this is not a coordinate. Not a coordinate. This is interval notation. This means I'm getting really, 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 really close. Really, really, really close to negative infinity on this side. And I'm including every single number until I get really, 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 really close to infinity. So this is the same thing as saying all real numbers. Okay? So all real numbers can be my output. So when I put in 4, I can get any number output that my heart desires, as long as it's a real number. So that is my range.